Our solar system is a huge and mysterious place. Planets spin around the sun, each with its own special story. But the real action is with the moons. These amazing objects, which we sometimes forget about, hold secrets about the universe. Moons are all different sizes, from small rocks to giant balls of ice. Some have air, some have volcanoes, and some might even have life. They're super interesting, and their stories are connected to how our solar system was made. When we study moons, we learn how planets form and change. We learn about what life needs, and if it could be on other planets. We're exploring our neighborhood in space. Uranus is a beautiful icy blue planet, often overlooked in the grand scheme of our solar system. Its serene azure appearance hides a world of fascinating mysteries and unique characteristics. One of the most intriguing aspects of Uranus is its unusual rotation. Unlike most planets, it spins on a tilted axis, almost lying on its side as it orbits the Sun. This tilt gives Uranus extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. But Uranus has another cool feature: 27 moons. These moons are like a cosmic entourage, each with its own unique characteristics and stories. They go around the planet like dancers in a celestial ballet, each one contributing to the intricate choreography of Uranus's gravitational field. Each moon has its own story to tell about the past. From the small, irregularly shaped moons to the larger, more spherical ones, they all hold clues to the history and evolution of the Uranian system. One of these moons is a giant, Titania. Titania stands out not just because of its size, but also because of its intriguing surface features and potential for scientific discovery. Discovered in 1787 by William Herschel, Titania is the biggest moon of Uranus. Herschel's discovery was a significant milestone in our understanding of the outer solar system. It's so big and has such interesting features that scientists really want to explore it. The moon's surface is marked by a variety of geological formations, including canyons, craters, and possibly even cryovolcanoes. Titania is made of ice and rock, and it's very mysterious. The combination of these materials suggests a complex geological history that scientists are eager to unravel. Its surface has lots of craters, which shows it had a rough past. These craters are like time capsules, preserving the record of impacts and collisions that have shaped Titania over billions of years. But under all that ice, Titania might have secrets that could change how we think about the outer parts of our solar system. Some scientists speculate that there could be a subsurface ocean beneath Titania's icy crust, potentially harboring conditions suitable for life. This makes Titania not just a moon of interest, but a key target for future exploration. What secrets does Titania hold? What can this icy giant teach us? Let's explore the mysteries of Titania. We'll uncover its history, its geology, and if it could have life. Come with us on a journey to Uranus's largest moon. We'll discover the wonders hidden in our cosmic backyard. Titania is the largest of Uranus's moons. It's much bigger than many other moons, over 1,500 kilometers across. That means you could fit almost 7 Earths inside it. That's how huge this icy giant is. But being big isn't everything. Titania is also the 8th largest moon in our whole solar system. That's like being in the same group as our moon and Jupiter's moon, Europa. Its size tells us it has a long and interesting history. Titania probably formed from the same gas and dust that made Uranus, which gives us clues about the early solar system. Studying a big moon like this helps us understand how our area of space was created. Planets close to the Sun are rocky, but Titania is different. It's an icy world. It's made of rock and different kinds of ice, like water ice, methane ice, and ammonia ice. This tells us it's very, very cold because it's far from the Sun. Imagine a place made of frozen water, methane, and ammonia. Titania's surface is always kind of dark because it's so far from the Sun. The icy plains, probably with lots of craters, have secrets we haven't discovered yet. Scientists think Titania has a rocky center under all that ice. This center is probably important for the moon's geology, like volcanoes and earthquakes. The ice and rock together make Titania a very interesting place to explore. Titania goes around Uranus about 436,000 kilometers away. That's 12 times farther than our moon is from Earth. It takes Titania about 8.7 days to go around Uranus once. But Titania's orbit isn't simple. Like Uranus, Titania is tilted. This tilt means Titania has really extreme seasons. Imagine a place where one side gets sunlight for decades and then it's dark for decades. This affects Titania's surface and maybe even if it could have life. Uranus and its other moons pull on Titania with their gravity. This creates tides that might warm up Titania's inside, which could cause geological activity. Understanding this helps us learn about how planets and moons interact. We've only seen Titania's surface with telescopes, but it's amazing. It has craters, which are like giant bowls made by things crashing into it. Some are bigger than the Grand Canyon. These craters tell us about a time long ago when lots of things were hitting the planets and moons. But Titania also has huge canyons, hundreds of kilometers long. These canyons tell us that things are happening inside Titania, changing its surface. There might even be volcanoes, although we haven't seen them erupt. One exciting thing on Titania might be ice volcanoes. These volcanoes would erupt with water, methane and ammonia, not hot rock. Imagine geysers of ice shooting into space. It was 1787. Lots of changes were happening in the world, but a different kind of change was happening in space. William Herschel, a British astronomer originally from Germany, was looking at the sky with his telescope. He didn't know he was about to find something amazing. Herschel, who had already discovered Uranus, was carefully studying the stars. He saw a small light near Uranus. It wasn't a star, it was a moon going around Uranus. This was a big discovery. Herschel had found a new world, and it helped us understand how our solar system works. William Herschel wasn't just an astronomer, he was also a musician. But he loved space so much, he built his own telescopes. He was very careful and worked hard to make them. Because of this, he could see farther into space than anyone else. Discovering Titania showed how good Herschel was at observing and how curious he was. He didn't just find Titania by accident. He was looking for new things in the sky. His careful notes and measurements helped other astronomers study Titania later. Herschel is remembered not just for his discoveries, but also for how much he wanted to learn about space. When astronomers find something new in space, they get to name it. Herschel loved books and stories, so he wanted a special name for this moon. He chose a name from Shakespeare's play. Titania is the queen of the fairies in the play. Herschel thought this name was perfect for the beautiful and mysterious moon. The name shows how Herschel saw space, a place of science and wonder. The name Titania reminds us that art, literature, and science are connected. It shows how humans find beauty and meaning in space. Herschel's discovery of Titania was part of a bigger change in science. People in the 1700s were very curious, and astronomy was very popular. New, powerful telescopes showed a universe full of stars, planets, and moons. Scientists were making new discoveries all the time, and each one changed what we knew about space. Titania's discovery showed how big and complicated our solar system is. It reminded us that we are a small part of a huge universe, and there's still so much to learn. Titania, made of ice and shaped over a long time, is a very interesting place for geologists. Its surface, with craters, canyons, and plains, tells a story of impacts and changes. Imagine huge ice plains, with big cliffs and deep canyons. The craters, some bigger than cities on Earth, show how chaotic the early solar system was. These craters tell us about what hit Titania billions of years ago. But Titania is more than just craters. The canyons, some thousands of kilometers long, tell us that things happened inside Titania, cracking its icy surface. People have always wondered if there's life on other planets. As we explore space, we look for signs of life, even in strange places. Titania's surface is very cold, but there might be life under the ice. Scientists think Titania might have an ocean under its surface, like its neighbor Ariel. This ocean, between layers of ice, could have life. Life as we know it needs water, energy, and organic molecules. These things might exist in Titania's ocean. We've found organic molecules, the building blocks of life on other icy moons. If Titania has them too, its ocean could have simple life forms. The idea of an ocean on Titania isn't just a guess. Scientists have some evidence. Titania has a very weak magnetic field, which is strange. This might mean there's something conductive under the surface, like a salty ocean. An ocean would affect the magnetic field, making it weaker. Also, Titania shows signs of past geological activity. The canyons and other features tell us that Titania's inside wasn't always frozen. Heat from inside, maybe caused by tides from Uranus, could have melted the ice and made an ocean. This ocean could be very important for how Titania changed over time. The idea of a hidden ocean is exciting, but Titania's surface also has mysteries. There might be ice volcanoes. These volcanoes would erupt with water, ammonia, and other things, not hot rock. If these volcanoes are real, it means Titania is still active. The eruptions would change the surface and maybe even add to Titania's thin atmosphere. Imagine ice geysers all over Titania. Another mystery is why Titania's surface has different colors. Some parts are darker, which might mean they're made of different things or have been exposed to more radiation. These color differences could tell us about how Titania's surface has changed over billions of years. We don't know a lot about Titania. Most of what we know comes from one quick visit from a spacecraft. In 1986, Voyager 2 flew past Uranus and its moons. It took the first close-up pictures of Titania, showing its craters, canyons, and interesting geology. These pictures made us want to learn more about this mysterious moon. Voyager 2 also measured Titania's size, mass, and orbit. This helped scientists learn more about the Uranian system and how Titania formed. But Voyager 2's visit was short, and we still have lots of questions. Voyager 2's visit was amazing, but it showed us that we need to get closer to Titania. We need a spacecraft to orbit the moon, take detailed pictures, and study its inside. This would teach us so much. Imagine a spacecraft with special instruments that could look under Titania's ice. Radar could map the ice and find any oceans. Other instruments could study what the surface is made of and look for signs of organic molecules. A mission to Titania would not only teach us about this moon, but also about how our solar system was made. We could learn about icy worlds, the possibility of life, and how planets and moons interact. We don't have a mission to Titania yet, but space exploration is very exciting right now. The advancements in technology and the growing interest in exploring the far reaches of our solar system have opened up new possibilities that were once only the stuff of science fiction. From the development of new propulsion systems to the miniaturization of instruments, the future of space exploration looks incredibly promising. New technology, like ion propulsion and smaller instruments, makes it easier to explore the outer solar system. Ion propulsion, for instance, allows spacecraft to travel faster and more efficiently than ever before. This means we can reach distant planets and moons in a shorter amount of time, making missions to places like Uranus and its moons more feasible. Scientists are thinking about a mission to Uranus and its moons with a spacecraft that could orbit the planet and send probes to study the moons, including Titania. Such a mission would provide invaluable data about the composition, atmosphere, and potential for life on these distant celestial bodies. The idea is to have a spacecraft equipped with advanced instruments that can conduct detailed analyses while in orbit. This would be an amazing chance to explore this mysterious system. Uranus and its moons hold many secrets that could help us understand the formation and evolution of our solar system. By studying these distant worlds, we can gain insights into the processes that shape not only Uranus, but also other planets and moons. Another idea is to use CubeSats. These small, inexpensive spacecraft can be deployed alongside larger missions, providing additional data and perspectives. CubeSats are revolutionizing space exploration by making it more accessible and cost-effective. These are small, inexpensive spacecraft that can travel with bigger missions. They can be equipped with a variety of instruments to study different aspects of the moons and planets they visit. For example, CubeSats could carry cameras, spectrometers, and other sensors to gather detailed information about Titania's surface and environment. We could send many CubeSats to study Titania and the other moons of Uranus. By deploying a fleet of CubeSats, we can cover more ground and collect a wider range of data. This approach allows for a more comprehensive exploration of these distant worlds, providing a clearer picture of their characteristics and potential for supporting life. Exploring Titania is like exploring a new world, an icy world at the edge of our solar system. Titania, with its icy surface and mysterious features, presents a unique opportunity for scientific discovery. By studying its geology, atmosphere, and potential for hosting life, we can learn more about the conditions that exist on other icy moons and planets. It's challenging, but it would teach us so much about planets, the possibility of life, and our place in the universe. The challenges of exploring such distant and harsh environments push the boundaries of our technology and knowledge. Each mission brings us closer to understanding the universe and our place within it, inspiring future generations to continue the quest for knowledge and exploration. Our journey to Titania shows us that even far away in our solar system, there are amazing things. Titania, one of Uranus's largest moons, is a world of wonder and mystery. As our spacecraft approaches, we are reminded of the vastness of space and the endless possibilities it holds. The distant view of Uranus and its moons is a humbling sight, a reminder of how small we are in the grand scheme of the universe. This icy giant, once just a small light in Herschel's telescope, is a complex world. The surface of Titania is a frozen landscape, marked by craters and canyons that tell a story of its tumultuous past. Through the lens of history, we see how far our understanding of the cosmos has come, from the early days of telescopic observations to the detailed images we have today. It has been shaped by impacts, geological changes, and maybe even a hidden ocean. The craters and geological formations on Titania's surface are evidence of the dynamic processes that have shaped this moon over billions of years. Some scientists believe that beneath its icy crust, Titania may harbor a subsurface ocean, a tantalizing possibility that raises questions about the potential for life in such extreme environments. What we've learned about Titania, even from far away, is important for understanding the universe. The data collected from our observations of Titania provide valuable insights into the formation and evolution of celestial bodies. By studying this distant moon, we gain a better understanding of the processes that shape not only our solar system, but also the countless other systems scattered throughout the cosmos. It makes us think about where life might exist and shows us how many different kinds of objects are in space. The diversity of celestial objects in our solar system is astounding, each one unique in its own way. Titania's potential subsurface ocean makes us ponder the possibility of life beyond Earth and the myriad forms it might take. This drives our curiosity and fuels our desire to explore further. Every crater, canyon, and icy plain tells a story, making us want to learn more. The geological features of Titania are like pages in a history book, each one revealing a chapter of the Moon's past. By studying these features, we can piece together the story of Titania's formation and evolution, and in doing so, gain a deeper appreciation for the complexity and beauty of our universe. Studying Titania isn't just for scientists. The exploration of Titania and other celestial bodies is a collective human endeavor. Amateur astronomers, students, and space enthusiasts all contribute to our understanding of the cosmos. Public space science events and educational programs inspire the next generation of explorers and scientists, fostering a sense of wonder and curiosity about the universe. It shows how creative humans are and how much we want to learn. From artistic interpretations of space to hands-on educational projects, our fascination with the cosmos manifests in many creative ways. These activities not only enhance our understanding of space, but also bring people together, fostering a sense of community and shared purpose in the quest for knowledge. It shows how astronomy, geology, and even mythology are connected. Learning has no limits. The study of Titania and other celestial bodies bridges multiple disciplines, from the hard sciences to the arts. Mythology and astronomy often intersect, enriching our cultural heritage and providing new perspectives on our place in the universe. The pursuit of knowledge is a never-ending journey, one that continually expands our horizons and deepens our understanding of the cosmos. Titania's story is part of a much bigger story, the story of the universe. Every moon, planet, and star has secrets and stories. As we explore space, we see how everything is connected. What we learn from Titania helps us understand how planetary systems form, how life might begin, and if there are other planets with life. The search for life beyond Earth is important for astronomers, and studying icy moons like Titania helps us in this search. If life can exist in an ocean under the ice on a moon far away, then maybe life can exist in many other places in the universe. Exploring our solar system is a journey of discovery. Humans are curious and want to explore the unknown. We've learned a lot about space, but there are still many mysteries. We want to go farther, learn more, and find the secrets hidden in the darkness. Titania, with its possible ocean, ice volcanoes, and interesting geology, is a great place to explore in the future. A mission to Titania would teach us so much and inspire future generations. We are entering a new era of space exploration. New technology is helping us explore new places. We need to keep exploring, discovering, and sharing the wonders of the cosmos with everyone.